So today our topic is combustion and flame, and by this combustion and flame we would mean that what is combustion and what is flame. And from starting combustion and flame, we should first know that what is about CNG, that is studied in last chapter. CNG, charcoal, petrol. Charcoal is from by burning of wood only, and therefore it is a better fuel than wood. Now this is burning of magnesium. After burning of magnesium, we found that it is MgO, magnesium oxide, because it is in the presence of oxygen, and therefore magnesium is left like that. And in the presence of oxygen, therefore we need oxygen, and it leads to magnesium oxide after the burning of magnesium. And what is combustion? Combustion. How can we define combustion? First we should say chemical process. This is the main definition, that we should say chemical process. Yes. Now what should we say next? It is a reaction to. Okay, first I am saying that how can we form that definition? It is a reaction. Yes, it is a reaction. And chemical reaction. Yes, it is a chemical reaction. And it with oxygen only, with presence of oxygen. As I said, that it is magnesium oxide with presence of oxygen. Now we should make the definition here. Yes, now here it is definition: a chemical process in which, yes, a chemical process in which a substance reacts with oxygen, or magnesium reacts with oxygen to give off heat. Its heat is given by that heat that is producing. Here it is the heat, and it is called combustion. That is a simple definition of combustion. Now we should move further. Now, if charcoal burns in air, wood is burned in air, then it produces charcoal. And now if charcoal burns in air, it would be better fuel than wood. Okay, it will produce carbon dioxide. Mostly it is always, if we burn anything, carbon dioxide would be produced. Like here is the activity where oxygen is needed. If we remove one stick, then it is like what do we say, like this thermaling. And by thermaling I mean that it is here it is unaffected. Okay, because it is receiving oxygen in enough. Okay, it's giving a, but here it is flickering. Why flickering? Because now it is only oxygen is coming only from above, but here oxygen is coming from down also. But here it cannot just glow because oxygen can't come in from anywhere, and therefore it cannot glow. Okay, so for combustion, our main topic, that what are the conditions necessary for that. And the first, for combustion is necessary that it should be air, and in brackets you should write oxygen too, or you can write oxygen and in brackets air, same thing. Okay, so now moving further, always, now here it is the same thing. It's just an example to use. And if anyone gets fire, we should cover it by blanket, because that the fire could not reach oxygen, and if it is not oxygen, then the combustion would stop at that time only. And now, yes, it is here Bojo asked that we have read about nuclear energy that our sun produces. That yes, it is about hydrogen bombs. What do they do? On the same topic, it's about producing its light, and because of that so massive explosion, it produces heat and energy. And that energy, and yes, that heat, if that heat, there is heat and energy, it automatically produces light. Okay, so that light has reflections and many more, that we can able to see moons, and we are able to see sun from our earth. Okay, so it is about hydrogen bombs and about nuclear reactions, about nuclear fissions and fusions. Okay, so that's about another thing. It's also combustion. Okay, now moving further, we are able to see that there are like fires in mostly California of USA, and about dry forests get fire easily, because now the next topic is ignition temperature. Okay, now what does ignition temperature mean? Ignition means the lowest. Okay, ignition means lowest, and temperature means temperature only. The lowest temperature at which the substance is able to burn, like if these trees are dry, so from only some it would burn, some heat it could burn easily. Now if you would, there is one more activity, that if you are taking a balloon, two balloons, and if you fill water, and in second it is already an air, okay, then if you burn both, you would see that this one would first it would be blackened, and then it would burn, meaning like blast, it would be blast, okay. But in second, where there is a water, it cannot blast, because if because the it due to ignition temperature. Because of the ignition temperature, what is happening, that this if this balloon is getting heated, but what happens that this balloon by conduction transfers that heat to water, and after water reaching its ignition temperature, only the balloon could blast, and that takes time for water to getting its ignition. Yes, there is an activity here, what I was talking, activity 6.4, to prove that about oxygen and ignition temperature. Now these were the two main things, and now we have to resolve this combustion. Not only this, but we can use water. By water, I mean that if there is fire in a place, we should mostly people do only water. But electrical appliances, we should not put water, as that could lead to that electricity could pass through water and reach the person who is throwing water on the building to start that fire. And for that, what do we do? Mostly, if you are constructing a building and there is an fire that takes place, then we should write it as a sand. Mostly people use sand, as sand could be a good alternative, as in construction places we easily find sand, and so we use sand. And inflammable substances. Now inflammable substances we can understand by calorific value. That is further ahead, calorific value. By calorific value, I mean that if of hydrogen, it is 150,000. Just imagine 150,000 kilojoule per kilogram. Okay, and whereas of cow dung cake is about 6,000 to 8,000, and of LPG, CNG is around 50,000, could be ahead or before, as it is not every LPG has same or constant. Okay, so it could change readily. LPG and CNG has the same, and we say liquefied petroleum gas LPG and compressed natural gas CNG. And now how can we control fire? As we are easily able to see that it can be exist by water. Okay, so easily by water, but sometimes you use sand, and or sometimes you just cut off the air supply. But in normal construction buildings, we cannot just cut the air supply, so therefore where with that we use. And now if there are you would see this box mostly, because it is safe. If there is any fire taking place, then this cylinder contains the carbon dioxide, and what happens that if this carbon dioxide just extinguishes that fire. Okay, so this is mainly CO2, carbon dioxide. Now types of combustion, one is rapid, one is spontaneous, and the other third is explosion. Yes. Okay, so explosion combustion. Rapid combustion, you would see the glass stove, and it burns rapidly. It does not stops. Spontaneous is that it suddenly burns. Like in rapidly, it burns with good pressure, and we know that it would burn now, and it burns rapidly. But in spontaneous, it suddenly bursts and it flames. It is not necessary that it would be rapid combustion, meaning it would be burned rapidly, but yes, it would burn suddenly. And the third is explosion. Explosion, it is nuclear reactions, nuclear fissions, and it could be explosion that it could just a big blast. Now flame. From flame, I mean that if you would see a candle flame, it is a yellow in color. Mostly, and in LPG it is blue in color. Why? It is because of the middle zone, outer zone. Outer zone is the hottest part of the zone, that is in the gas stoves, and the middle zone, that is above candle, mainly of candle. By candle, that produces light, and it produces light, and therefore we use as candle. And here we would talk about structure of flame: outermost, middle zone, and innermost. Innermost is about wax. Here is a proof for that everything. Okay, now this was done. Now outermost, the middle zone. Outermost is for more heated, like it would produce heat in more quantity, and the middle zone produces light in more quantity, and the lower zone has unburned wax molecules. Now, what is a fuel and how can we define? Now, yes, this is a hotter pass. This same thing. Moderately hot. Yes, yellow candle, blue LPG, wax candle. Here is the innermost, and least hot. Least hot is this. Okay, if you would carefully look onto it here, is the innermost. Okay, now mostly the goldsmiths like how can they like melt that gold? So they blow the outermost zone, and the middle zones melt the middle zone melt the gold, and then they form initially that the customer wants, and therefore this is about that. Now yes, I was talking about calorific value and fuel efficiency. The fuel should be ideal fuel. By ideal fuel I mean that it should be ideally used, and it is better for transportation. It is better, it leads lesser residue, and like that. And it should not, yes. So the calorific value, the main SI unit is kilojoule per kilogram. And here is the list, and here hydrogen is 150,000, around 50,000 diesel, methane, and CNG, LPG around 50,000. It is mostly 55,000, and sometimes it is 50,000 too. Incomplete combustion could produce carbon monoxide gas, so we should not just close all our rooms, and heating should be there, or else we would die also. It could lead to dying. Okay, so we have like harmful products like carbon dioxide, carbon monoxide, and when they go in air, they with the clouds they form the acid rain, and that acid rain can cause like the Taj Mahal, yellowing of that white marble of Taj Mahal and everything. It could damage our trees, it could damage our monuments, everything. So we should stop, and there was a committee, Taj Mahal committee, to stop this everything. Okay, so that was Taj Mahal committee. And where we talk about everything like calorific value, combustion, deforestation, explosion, flame, fire extinguisher, like carbon dioxide, fuels like LPG, fuel efficiency, like ideal fuels or ideal fuels, and what is the efficiency of that. So mainly hydrogen gas, global warming. It could if we are burning anything with combustion, it would lead to global warming. Ideal fuel is CNG that we should use in cars. Ignition temperature, the lowest temperature that any substance needs to burn. Inflammable substance that it could easily burn, the ignition temperature is low, like paper. Okay, so by here I conclude my class. Thank you.